So a brief follow-up onto my previous video, which I'll link below, about using AI for better encryption in NVIDIA is there's a bunch of other benefits I forgot to talk about, such as reducing bandwidth needed for a bunch of tasks. It also, this whole thing requires a new design for a new type of computer chip based on something called GPUs and TPUs, and which will progress graphic and AI and pattern recognition technology, but also just speed at which things are handled by a great amount. So CPUs, central processing units, are the typical technology used in a lot of computers that you've heard about. And basically they handle big calculations or bigger calculations well, and are not made for very much power calculations. A lot of these things are changing, like the exact boundaries, but the next one is GPUs, graphic processing units, and they're made for specifically graphics and video runs, even though they use a lot of AIs, and they can handle many small calculations at once, and they also can retrieve the data, and their memory is also distributed throughout the whole thing, so they don't have to go all the way to a big bank some far away for data. Data is closer by, but it also means that when you need a lot of data at once, it might not be as good if you need a big chunk of data in one place, because you can't store a big chunk of data in one place as well. So it's pros and cons. Another way of thinking about it is, would you rather have 5,000 people working independently each with their own notebook, or one central project manager that's just giving out notes to everyone? Sometimes one might be better than the other one, but GPUs have recently been heavily invested on because we need better and better graphics for everything from better computers to more and more movies to video calls, and graphics are really taking off. But they also can handle data streaming better with different streams of data coming in and out. But a big one is in artificial intelligence, because artificial intelligence, what you do is you have a lot of little things. They call them neurons. Sometimes they call it neurons and neural network stuff. But they each take a little bit of data, do a simple calculation, and send to another one, like your brain. Like your brain is composed of many, many cells all over the place that each do a little bit of data here and there. And each cell can store memory and everything. So GPU is much more like your brain. And it's a lot better. And your brain doesn't do huge numbers times each other. We're so much more intelligent than a computer. That's the average person times a number in the millions times another number in the millions, and they can't do it. Well, a computer can easily do it because that's an extreme example. A CPU can handle much bigger calculations, but can't handle as many little calculations. Well, we can take little calculations all over the place from sensory data, figure out where there's always, we can recognize 20 different people's faces at once and all these other little things. The most extreme to take GPUs to the more extreme is a TPU. And TPUs basically translates for tensor product unit, and they're even more spread out than CPUs. They're like GPUs taken to more of extreme, and they're made for artificial intelligence. And you take out some of the graphic capabilities, like GPUs have stuff specifically built in them just for graphic calculations, such as putting the skin on stuff. And putting the skin on stuff is taking a picture. It's for use in 3D graphics, and not all GPUs have it, but it's how do you make a ball have the color painted on it when you rotate the ball or something like that, where you look at only surface stuff. TPUs and CPU, everything is moving more into the kind of, GPUs are trying to slowly replacing CPUs. They're also moving more into TPUs, and TPUs are becoming also moving more into GPUs. So CPUs are kind of getting kicked out, and GPUs are spreading down. But NVIDIA, this video conferencing call technology that NVIDIA uses a specific new GPU that they're developing, which will promote the development of GPUs for artificial intelligence greatly. And it will also promote the development of TPUs where consumption of it and start really kind of compute chip armways, but they'll also start to be using servers and stuff for data streaming stuff, which will lead to probably massive increases also in artificial intelligence, but in data streaming capabilities, and just also really complex simulations. Like many simulations, you don't need to handle as big numbers, you just need to handle many. And that comes anything from simulating how molecules move, simulating planets, to aerodynamics and all these other ones. It also could lead to a lot better electronics that react faster. Like, if you're talking about car driving, it doesn't need to calculate. When you're driving a car, you don't calculate really fancy math to calculate how something is pulling you, how fast it is to the 1/1,000,000th of a mile per hour. I'm exaggerating. You have to calculate all these little things at once and then react very fast. That's what GPUs and TPUs things. They can do many calculations really fast. So it will lead to better, more responsive electronics for also aviation, for spacecrafts, and all these other things. So this is a side benefit of this that I just wanted to delve into a little bit. Thank you for listening. As always, please like and subscribe. I'm trying to reach 1,000 subscribers in a year, which is really hard, and 40,000 watts hours. But I think together we can do that. And if you know, and please also share it. Also, if you feel free to leave a comment behind or any questions. Thank you very much.